In this video, some molecules are given to us and we are asked to draw electron dot structures for the given molecules. The first molecule which is given is methane, CH4. This molecule is made up of 1 carbon and 4 hydrogen atoms. In this molecule, carbon is the central atom because carbon can form covalent bond with more than 1 atoms. Let's see what is the electronic configuration of carbon. Carbon, atomic number 6. Carbon belongs to group 4th A of the periodic table. We write the electronic configuration of carbon, atomic number 6. In the K shell of carbon, there are 2 electrons, while in the L shell, there are 4 electrons. So, there are 4 electrons which are present in the valence shell of carbon. Carbon needs 4 more electrons to complete its octet to get the stability, to get the electronic configuration similar with the noble gas. On the other hand, we have hydrogen atom in methane molecule, hydrogen atomic number 1. The electronic configuration of hydrogen is, in the K shell, there is just 1 electron. Hydrogen needs 1 more electron to complete its duplet in the K shell, in the first shell, to get the similar electronic configuration like helium. So, carbon will share 4 electrons with 4 hydrogen atoms to form a molecule of methane. Let's see the electron dot structure for methane molecule. Blue balls show the electrons of carbon, while electrons of hydrogen are represented with the help of white balls. So here carbon will share its electron with hydrogen, 1 electron of carbon and 1 electron of hydrogen. Similarly, here we have one carbon share its electron with hydrogen, and here we have 1 electron of carbon and 1 for hydrogen. Similarly, here 1 electron of carbon and 1 electron for hydrogen. Now, after sharing, we will count the number of electrons. Here we can notice 1, 2, 3, 4, 5, 6, 7, 8. Carbon share 4 electrons with 4 hydrogen atoms. After this sharing, octet of carbon is completed. Now its electronic configuration is similar with the nearest noble gas. Now it becomes stable. Let's see hydrogen after the sharing of electron. Here we can notice each hydrogen atom has completed its duplet in its first shell. So hydrogen also becomes stable. This is the electron dot structure for methane. I hope this structure is clear to you. The next molecule which is given to us is water molecule, having the molecular formula H2O. In this molecule, oxygen is the central atom because oxygen can form bond with 2 hydrogen atoms. Now, in order to draw its electron dot structure, first of all, we will write the electronic configuration for oxygen as well as hydrogen, and then we will see how many electrons are shared between oxygen and hydrogen to get the stability. Now, first of all, we will write the electronic configuration for oxygen. We know oxygen is a member of group 6A of the periodic table. Atomic number of oxygen is 8. In the K shell of oxygen, there are 2 electrons, while in the L shell, there are 6 electrons. Oxygen has 6 electrons in its valence shell, which is the L shell. Oxygen needs 2 electrons to complete its octet to get the stability, to get the similar electronic configuration with the noble gases. Now, in the water molecule, the second atom, which is hydrogen, hydrogen atomic number 1. Now, we will write the electronic configuration for hydrogen. Hydrogen is the member of group 1st A of the periodic table. Atomic number of hydrogen is 1. Hydrogen has just 1 electron in its first shell, that is in K shell. Hydrogen needs just 1 more electron to complete its duplet in the first shell to get the similar electronic configuration with helium to get the stability. So, oxygen will share its electrons. Let's see the electron dot structure for water molecule. Here we will show the electrons of hydrogen with white balls, while the electrons of oxygen with blue balls. So in the valence shell of oxygen there are 6 electrons. So we place 6 electrons here. 1, 2, 3, 4, 5, and it will share. This is white ball, which is the electron of hydrogen. Here, this is the electron dot structure for water molecule. Blue balls represent the electrons of oxygen, while white balls represent the electrons of hydrogen. Now after this we can count the number of electrons for oxygen. Now after sharing electrons with hydrogen, the octet of oxygen is completed. 1, 2, 3, 4, 5, 6, 7, 8. Now oxygen becomes stable, since electronic configuration of oxygen becomes get matched with the noble gases. After the sharing of electron with oxygen, hydrogen has completed its duplet and its electronic configuration gets similar with the helium. Each hydrogen has 2 electrons in its case shell. I hope electron dot structure for water molecule is clear to you. We will write the electronic configuration of carbon and oxygen. Carbon, member of group 4th of the periodic table. Atomic number of carbon is 6. In the K shell of carbon, there are 2 electrons, while in the L shell, there are 4 electrons. 4 electrons are present in the valence shell of carbon. In order to complete the octet, carbon needs 4 more electrons to get the stability, to get the similar electronic configuration with the noble gas. Similarly, if we write the electronic configuration for oxygen, oxygen is a member of group 6 of the periodic table. Atomic number of oxygen is 8. We write the electronic configuration for oxygen. In the K shell of oxygen there are 2 electrons, while in the L shell of oxygen there are 6 electrons. Oxygen needs 2 electrons, 2 more electrons to complete its octet to get the stability. So, since carbon needs 4 electrons and there are only 2 oxygen atoms in carbon dioxide, so it will share its 2 electrons with each oxygen atom. Let's see what is the electron dot structure for carbon dioxide. Now here we will write the electron dot structure for carbon dioxide. We will place the blue balls which represent the electrons of oxygen, while yellow balls represent the electrons of carbon. So we will place the electrons of oxygen here. 1, 2, 3, 4. Each oxygen share 2 electrons. 1, 2. Similarly, we will place these electrons for this oxygen. 1, 2, 3, 4, 5, 6. Now we will place the electrons for carbon. 1. Each carbon share 2 electrons. Here, similarly, carbon share 2 electrons with oxygen atom. So, carbon will share 2 electrons with each oxygen atom. After sharing, we will see the octet for this carbon is completed or not. Now for this carbon, it has now 1, 2, 3, 4, 5, 6, 7, 8. Now the octet of carbon is completed after the sharing of electrons. Now this carbon becomes stable. Now let's see the 4 oxygen atoms. For this oxygen atom we have 1, 2, 3, 4, 5, 6, 7, 8. Octet of this oxygen is also completed. Similarly, octet of this oxygen is also completed. So this is the electron dot structure for carbon dioxide. I hope this structure is clear to you. The next molecule which is given is hydrogen cyanide, HCN. To show its electron dot structure, first of all we will write the electronic configuration for carbon, hydrogen and nitrogen. Let's write the electronic configuration. Hydrogen, the member of group first of the periodic table, atomic number 1. Hydrogen has 1 electron in its first shell, that is in K shell. Hydrogen needs just 1 electron to complete its duplet in its first shell and get the stability, get the electronic configuration similar with helium. Carbon atomic number 6, member of group 4th A of the periodic table. In the K shell of carbon there are 2 electrons, while in the L shell there are 4 electrons. So carbon needs 4 electrons to complete its octet. Similarly, nitrogen, atomic number 7, electronic configuration for nitrogen. In the K shell of nitrogen there are 2 electrons, while in the L shell there are 5 electrons. Nitrogen needs 3 more electrons to complete its octet to get the stability, to get the electronic configuration similar with the nearest noble gas. Since we know carbon needs 4, nitrogen needs 3 electrons and hydrogen needs just 1 electron to complete its duplet. So carbon share 1 electron with 1 hydrogen atom to form a single covalent bond, and 3 electrons with the nitrogen atom to form a triple covalent bond. This will satisfy the octet rule. Let's see the electron dot structure for hydrogen cyanide. Now here we will see the electron dot structure for hydrogen cyanide. Here we will place this blue ball represent the electron of hydrogen. White balls represent the electrons of carbon, while yellow balls represent the electrons of nitrogen. So here we will write the electron of hydrogen will share its 1 electron with carbon to complete its duplet. Similarly, there is a triple covalent bond between carbon and nitrogen. So here we make the triple covalent bond between carbon and nitrogen, that is 1, 2, and nitrogen has 2 electrons here. So after placing these electrons, now we will see for carbon atom how many electrons are present now. 1, 2, 3, 4, 5, 6, 7, 8. Octet of this carbon is completed. Now carbon becomes stable. Similarly, if we see the nitrogen atom, 1, 2, 3, 4, 5, 6, 7, 8. Octet of nitrogen is also completed. Nitrogen becomes stable, and duplet of hydrogen is completed. Hydrogen becomes stable. So in hydrogen cyanide molecule there is a single covalent bond between carbon and hydrogen, while there is a triple covalent bond between carbon and nitrogen. I hope electron dot model for hydrogen cyanide is clear to you.